Hello and welcome to a new episode of the Data Shaman series in which we explore several techniques and tips and tricks for people who don't have any coding experience or are interested in learning some and maybe finding some ways to make smart decisions for them to optimize their their code, their thoughts, their life, whatever it is. I think you could do that. We could all do that, whether you're a data scientist or not, whether you know how to code or not. Okay, so today, actually, in order to set us, I'd say, to make this a playground, okay, I am going to explore a new package with you guys. So I have never used this package before with some basic Python coding. You could do that with me. And if you check out our previous tutorial, the one I posted on the 22nd of November, you're gonna see that there are what you need for you to learn this package with me at the same pace. Okay, so this package is a graphic package, and it just helps us draw some cool things, some algorithmic and generative art that you could even sell as NFTs. Just saying this. Okay, so all you guys need is Python and this package that is called Turtle. Let me see, I think I opened it here. See, turtle graphics. All you need is to import that, and then you have some basic shapes. Okay, here are the commands that you have, and here are some examples. Okay, so basically Turtle is like a drawing pen, and you decide how to move it, like where to move it and whether to draw or not draw. Okay, so let's get started. We are gonna use Jupyter for this. Oh, sorry, that looked like Jupyter. Here it is. Okay, I am going to open a new notebook in which I am going to import Turtle. So we're gonna get everything from Turtle. I don't have it installed, I think. Oh, I do actually. If you don't have it installed, you just do pip install Turtle. Okay. So let's see, what are the basic things. So these are just like if you want to move it a tiny position at every time. Okay, Turtle home takes it home, position, heading. Okay, let's try the one that they are showing us here. So as you see, color, it just opened the Turtle graphics here. Okay, next it's gonna fill that. Let's see, where is it? Okay, here we go. Just keeping this here. Next, so as you've seen before, we had explored the while function in our previous Python basic tutorial. We've explored the while and the for loop. So here what it's saying is while true, which means keep infinitely going into this loop until, for example, I say break, or I say a condition is met. Okay, so forward 200 means go take this turtle forward 200 this way. 200. Okay, then left 170 degrees. Okay, and then so what this is doing, if the absolute value of the position is less than 1, then break. Okay, what this is doing is that if it goes to like anything less than 1, 0 point something, or negative 0 point something, then stop, because it would have come back to where it was. It would have completed the whole loop, the whole okay, now we have to do end fill and done. So fill is like the pen down thing. Okay, ready? So we're gonna run this and look at it while it paints. Here we go. Okay, it's exciting. So the position has always been either much like above 1 or less than -1, and we could always print the position if you have any doubts about this. So where's our Jupiter? Here we go. Now let's say we want to change this a little bit. Okay, if you want to do something like maybe have a different angle, let's say 120, see what this gives. Oh, you need to reset this. Actually, stop. And then interrupting kernel. Come on. Okay, I guess now we could run this. See? 120 degrees just makes a triangle. 160 degrees, I don't know. Stop. I'm sure there is a clear function. No. Well, actually we have to make sure that this stops the kernel so that we could run this again. There is no clear. Yes, there is a clear. Okay, and now let's run this again for 120 degrees, 160 degrees. Here we go. Okay. We should have done the clear before the begin fill, otherwise we would lose colors. Okay. So now we could try something else. Okay. What happens if we forward 50, and then we're gonna do backward 20. Okay, who wants to see that? Problem is that every time this thing, okay, it's much better to actually run this on IPython. Here we go. Clear and then run it. Interesting. Okay, so we could do much more than that. Many more complicated equations. We could play with the speed. So this is the pen down, so it could be moving and not writing. If the pen is up or pen is down, the pen size could change. So let's see, forward, let's say 250. Okay, and then let's say that pen size is equal to 5, while here the pen size is let's say it's 2. So the backward is going to be double the thickness, or a little bit more than double the thickness. Okay, stop. Come on, baby. This is always a problem here. Stop. Come on. Okay, now we could run it again. Run this and then run this. Actually, we could have done all of this together. Okay, run. Let's see. Cool, no? Okay, so let's see. What can we do again? So the pen size here. Let's say we could play also with size mode set on click. So while this is going, we're gonna add a tiny little thing that says on click. No, I need to see an example of this. Okay, on click, screen.onClick, turtle subsequent clicking into turtle screen will make the turtle move to the click point. Oh, nice. Yes, I like this. So so this has to be here somewhere. Screen.onClick. Okay, turtle go to. Okay, which makes the turtle go to where we click. Apparently not, because screen is not declared. Maybe. What happened? Yeah, maybe there's nothing as screen yet. No screen. So we have to declare screen somehow. Control F, screen. Okay. Okay. Screen.listen. So whatever we type here, that's fantastic. Circle.onKey. Okay, so how do we create screen? Maybe there's a class called screen. Should be here somewhere. Turtle screen, here we go. Screen equal screen. Can we try this? Yep. Okay. So this does it. Screen.in. Let's try if this works. No. Turtle is not defined, of course. What do you mean turtle? Oh, okay. Turtle to go to. So let's say pen size, will this work? 10. Okay, if we click on the screen, no, didn't work. So the screen actually reset the colors to black. So by default we have screen running here. Stop. So in this loop, on key press. So def f screen dot on key screen dot listen. Takes a function. Wow. On key runs the function. Yeah, we were able to make a sun. I think this is pretty good. You see, you could do other things. You could do, let's say here, for I in range, say range 70, range 60. Let's say we are going to forward as much as I, and then we are going to how do we rotate? I forgot the angle. Yeah, left. Okay, let's say right. Right, let's say it's always gonna be 20, and then back is gonna be fixed, let's say 10. Okay, let's see what that gives. Oh. Wow, see, I just made this up. We could color it, we could do whatever we want to it. And you could do that because everything here has been covered in the previous tutorial, Python introductory tutorial. Okay, so we could make this even cooler. It looks like an optical illusion. For I in range let's go far. Okay, the thing is, I think it's stopping. Yeah. And then how about let's have these colors declared here. Here we go, run. Wow. Ain't that something? Ain't that something? So you could mint this as an NFT, as algorithmic art. Wait for the colors now, the filling colors. I think this is gonna turn into yellow and red. Except this is gonna take a while. And the reason for this is 120. So now each one of those is taking a lot more than the tiny ones. Here we go. Here we go. Wow. You look at this for more than a minute and start hallucinating. Okay, what can we do here? So if it takes a long time to render, you could do turtle speed, right? I don't know what's the default. Turtle speed. Well, I was expecting this to be yeah, so let's close this one. Turtle speed. Speed. Oh, just speed. Yeah. Just speed. Turtle.speed. So speed. I don't know, 50. Is that fast enough? So now what happens if the angle is a little bit more? 50. More inwards, okay? What's going on here? Color. Color has an issue. Okay. Wow, ain't that something? So I seriously did not expect this to look that good. Wow. This is really cool. I think I'm gonna save this. Okay, I mean, at least take a screenshot. Okay, see, you could do some really exciting things. I don't know why the color did not work here. I think we have to close this. Where is it again? We have to run this separately. No, we have to actually stop the whole thing. Where is that window? Not you. I think the window is gone. Run. Yeah. So now we have a red and yellow color. Can we keep this up? Always on top. Here we go. I think now that should do it. Okay, let's run this with 60 degrees, huh? You see a tiny little difference. Wow. These are cool. These are cool. Actually, I like more the 50. And instead of 10, let's do 20 back. See what that does. Except that now I do have to close this so that I could run this again. First run this and then run this. Wow. This is dope. I actually like, let me see, purple and black. Shades of purple and black. See, how was it before? Yellow was here. I think I want the purple to be here. And this to be yellow. Okay, does this make sense? Okay, let's try that again. Okay, so now we're gonna make it faster. 70, going let's say right 50 back, and then we could have a little left here, left 5, just 5 degrees. Okay, okay, wait till it's filled. Wow, that's pretty cool. Okay, now you can have much more advanced functions here. You could left just 1 and right 51. Oops, no, I have to kill this actually. Run this and then run this again. Yeah, this is gonna be cooler. I don't know if you could see. Actually, to better see this, I think black would be. Yeah, this is really nice. Wow, this is an optical illusion. I could see it move it. I could see this moving. I like this a lot. So let's try one last one. Forward. Now instead of I, you could use I times 2, for example. Okay, so this is gonna like go super fast in terms of size. Sorry. Okay. Oh. Ain't that cool? So this is the squared instead of the linear. It's a quadratic equation now in terms of length. So you see the length is just growing very much faster in terms of the edges length. What can we do? Last one, maybe last one. Back. So the back could be also a function of I, just the way forward is, or even the angle could be a function of I. What if the left, I think this might not converge even. What if the left was a function of I divided by 2? Because we don't want it to go so much. Divide by 2 is going to reach 120, which is fair enough of a span between 0 and 120 degrees. Okay, let's run this and then run this. Here we go. Yo. Okay, it just like left the scene. It was so fast at growing. It's what I kind of expected. The thing is, we don't want it to grow that fast. So we want the angle to be either tiny or rather than growing this angle, we're gonna grow, oops, so keep this 1 and just grow this angle. Right. I divided by 4. Okay, let's run this and this. Run. Oh, because we haven't closed it yet. Have we? Yes, here it is. Run. Oh wow. So it's a bit off-centered because until it yeah, the angle was so low at the beginning, so we could have a range for the angle. Instead of it being divided by 4, we want it to kind of let's say be 40 plus I square root of I. Oh, there's no square root function. How about I to the power 0.1 actually. Okay, tiny changes are being made to this. That could be very interesting. Run. Run this again. Here we go. See, it's these tiny little imperfections that we introduce that make this very interesting. Wow. See, this is this has a lot of personality in it, a lot of character, I think. Yeah. So that's gonna be it for today. You could crop it the way you want. You could stop it at here. You could edit it. You could take a screenshot and replay it and do whatever you want. You could remove, play with these parameters, and yeah, you could sell it as an NFT. Whatever you do, subscribe, and see you next time.